What happens when you accidentally register the same AI tool twice? Should it silently replace the original, ignore the duplicate, or fail fast with an error? We'll configure a FastMCP server to explicitly handle duplicate tool registrations, showing how to enforce strict tool naming policies that prevent accidental overwrites. You'll see exactly what error gets raised when attempting to register a duplicate tool name and how to choose between different conflict resolution strategies. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals strict server. Hash configure behavior for duplicate tool names. On duplicate tools equals error. At MCP, tool. Def my tool, return version 1. Hash this will now raise a value error because my tool already exists. Hash and on duplicate tools is set to error. Hash at MCP, tool. Hash def my tool, return version 2. This demonstrates the duplicate tool handling pattern in FastMCP, where the framework enforces strict tool registration policies through server-level configuration. The concept revolves around treating tool names as unique identifiers within a server instance, with configurable behaviors when conflicts arise. What makes this distinctive is the separation between tool definition, your Python functions, and registration policy, server configuration, allowing you to control naming collisions at the infrastructure level rather than in individual tool implementations. The pattern works by centralizing duplicate resolution logic in the FastMCP server constructor, where the onDuplicate tools parameter defines the global strategy for name conflicts. When a tool decorator executes, the server either accepts the registration, rejects it with an error, or applies the configured resolution policy, all without requiring manual checks in your tool code. This design keeps your tool implementations clean while giving administrators control over server-wide consistency, whether they prefer strict enforcement, error mode, or flexible replacement, replace-ignore modes. This approach matters because it prevents silent bugs that occur when tools accidentally overwrite each other, while still accommodating scenarios where dynamic tool replacement is desirable. The strict error mode shown here is particularly valuable in production environments where tool name collisions could indicate deployment issues or version mismatches. By failing fast during server initialization, you catch configuration problems early rather than discovering them through runtime failures. The trade-off is explicitness over convenience. You sacrifice automatic overwrites for predictable behavior, which is often the right choice for stable systems. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tool collections. It handles tool registration, duplicate detection, and exposes Python functions to AI models as structured tools. MCP equals FastMCP. This instantiates the core FastMCP server, the central orchestrator for AI-callable tools. The instance manages tool registration, duplicate handling, and runtime execution, all configured through its constructor parameters. Name equals strict server. This sets the server's human-readable identifier to strict server, critical for logging, debugging, and distinguishing between multiple MCP instances in distributed systems. Hash configure behavior for duplicate tool names. On duplicate tools equals error. This configures duplicate tool handling to raise an error, preventing accidental overwrites. Without this, duplicate tool names would silently replace existing tools, creating subtle bugs. The error setting enforces explicit tool naming, maintaining predictable behavior. This closing parenthesis finalizes the FastMCP instance configuration. It locks in the duplicate tool handling policy we set to error, enforcing strict tool name uniqueness.
At MCP, tool. Def my tool, return version 1.
This decorator registers my tool as an AA callable function in FastMCP. The function name becomes the tool identifier, and its return value defines the output schema for AI interactions. The duplicate name check from the onDuplicate tools equals error. Setting means this registration will fail if another tool with the same name exists, enforcing strict tool naming.
Hash this will now raise a value error because my tool already exists. Hash and onDuplicate tools is set to error. Hash at MCP, tool. Hash def my tool, return version 2.
This commented out duplicate tool demonstrates FastMCP's strict mode for tool registration. When onDuplicate tools equals error, attempting to register a tool with an existing name raises a value error, preventing accidental overrides. This enforces explicit tool naming and avoids silent conflicts in production. FastMCP tool registration. The duplicate tool handling behavior in FastMCP2 demonstrates how strict naming policies prevent accidental tool shadowing in production systems. Setting onDuplicate tools equals error forces explicit resolution of naming conflicts rather than silent overwrites. This pattern ensures tool registries remain predictable and debuggable at scale.
The server that refuses duplicate names becomes the only server that truly knows itself.